question 1. So question 1 tells us to, part A says, draw the graph of K5. So we've got this clear section here, which we can use to draw our graph. We're going to have 5 nodes because it's K5, and it's going to be fully connected. So I'm going to draw on my 5 nodes. You can put them in any configuration, but this is probably the most standard. And then I'm going to connect them all to one another. Now, when you do this, the more nodes that you have is slightly better to have a systematic approach. So my technique is I usually close in the shape, and then I go around node from node and make sure those nodes are all connected together. So now this node has connected everything. Now if we go here, I need to connect it to here, and here, and then finally up here to get our final one. So now we can see that all nodes are connected to the 4 other nodes in this. So part B, the first part says, in the context of graph theory, explain what is meant by semi-Eulerian. So to be able to work this out, we're going to use the lines to write our answer. So a semi-Eulerian graph has one pair of odd-ordered nodes, and all of the other ones are even. So we're going to put this down. So a semi-Eulerian graph has one pair of odd-ordered nodes, and all other nodes are of even order. So then for part 2, it says draw 2 semi-Eulerian subgraphs of K5, each having 5 vertices but with a different number of edges. So to be able to do that, if we look through our pack, we'll have another clear space to be able to draw them. So B part 2. Again, I'm going to start off with my shape for K5. I'm going to draw 2 of them because it said to draw 2 subgraphs. Semi-Eulerian means that we need to have every one of them having even order and just one pair of odd. So if I connect round, there's lots of different answers for this, but these are just 2 of them. And so I can now see that here, even, and even. So we need to connect to make one pair of odd. So I'm just going to connect down here. So now this is odd and this is odd, but the rest remain even. And we need it to be a different one this time. So I'm going to just draw a different graph. So I'm checking here, right, this one's even, we've got an odd here and an odd here. So I'm going to keep those odd ones there. I'm just going to keep them with order 1. I need to connect down to these 2 as well. So that's now odd up here. This is odd, so that's a slight issue. So now I'm going to connect another one there. Even, odd. But if I connect these 2 together, we then get all of them even apart from that one and that one there. So part C says to us to explain why a graph with exactly 5 vertices with vertex orders 1, 2, 2, 3, and 4 cannot be a tree. So this is testing our understanding of what a tree is. So let's use our knowledge of a tree to be able to work this out. So a tree which has 5 nodes or 5 vertices would have 4 arcs connecting them together. So we need to see how many arcs do we have in this graph. To work out the number of arcs, we can add them all together. So 1 plus 2 plus 2 plus 3 plus 4, and we can half that. That gives me 6. So we're now going to conclude a tree with 5 vertices would have 4 arcs, not 6 arcs. So therefore it cannot be a tree.